Okay, it's about the oxidation reaction. In the oxidation reaction, the addition of oxygen or removal of removal of hydrogen is called, or loss of electron of loss of electron is called as an oxidation reaction. Oxidation, in from name itself you can understand, oxidation, it favors oxygen, so addition of oxygen and removal of hydrogen, it's always anti of hydrogen, okay, and removal of electrons, because you can tell that hydrogen has only one electron, so it's almost similar. So addition of an oxygen or removal of hydrogen or electron is termed as a oxidation reaction. It's termed as oxidation reaction has taken place in that element. And the next is a reduction reaction. It's an opposite of the oxidation reaction. Here the addition of hydrogen, removal of oxygen, and gain of electrons. You can see here addition of oxygen, here removal of oxygen, here removal of hydrogen, here addition of hydrogen, here loss, here gain of electrons. So it is an opposite of this thing basically. So you see here Mg, oxygen is added, so it oxidation has taken place in the same way. Here copper oxygen is added, Cu, C has changed to Cu, so oxygen is added. So here you can tell it's an oxidation reaction, and this is a redox reaction. It's a very important thing to be observed, is that any reaction doesn't take place like an oxidation reaction and or the reduction doesn't take place singularly. Both are accompanied by each other, means both takes place simultaneously. Okay? If this is done, then compulsory. If one reactant is reduced, then the other is oxidized. It's compulsory. It's like Newton's laws, right? If anything force is applied, the force is also, it's like applied back. If you apply force on something, it's the same as applied back. In the same way here, both are done simultaneously. This both happen simultaneously. When you apply force on the ground, the ground also applies a force on you at the same time simultaneously. Sorry, but on different objects. Okay, here the reaction involving both oxidation and reduction is termed simultaneously. Is a very important word. Simultaneously is called as an oxidation reduction reaction. To be more clear, let's see this. CuO plus hydrogen. So CuO is adding of hydrogen. It is reduced, and among other thing is oxidized. Okay, exothermic reaction. So here exothermic reaction means heat is liberated or heat is given out. It means that after the reaction is occurred, the container contained the reactants or the products becomes hot. Okay, heat is evolved, heat energy is evolved. You don't need to supply heat for it. It itself liberates heat. You can also represent it like this: x plus y gives z plus q, or x plus y minus q gives z, or x plus y gives z. Delta H is equals to negative, I think it's No, I'm sorry, it's negative, I suppose. I'm not sure, I'm not actually sure about it, but just forget about it. Okay, these things are important, just learn these. Okay, the next is neutralization reaction. In neutralization reaction, what happens, the acid reacts with the base together to form a salt and water. So here, this is an acid, this is a base. Anything which contains OH minus ion is a base. Anything that contains H plus is generally an acid. For now, you learn more about it in the ionic equilibrium chapter in the class 11th, not now. In H2O, water is formed, and this is salt. Sorry. And this is a salt formed, okay? And the next is the very important topic of this chapter, the law of conservation of mass. You've learned about it in the class 9th itself. Matter is conserved, energy is conserved, etc. Other things are conserved. Even momentum is conserved. It means that substances in the LHS is equals to RHS. This is mean by the conservation. Nothing more than that, okay? When balancing chemical equation, the formula shouldn't be changed. For example, this is Mg plus O2 gives MgO. Here O2 is there. You cannot add here O2. You shouldn't do that, okay? You cannot alter this place. You should use only these coefficients to balance the reactions. So this is wrong. This is wrong. And the right way is this: Mg plus O2 gives 2MgO. You should add here and not here in the chemical formula. Okay, not in the formula. Only this is called as coefficients or the stoichiometric coefficients. This is an example which you can look after. It's not necessary, it's easy for you to understand. And the next is the process of corrosion. Process of slowly reacting process of slowly reacting above things, the atmospheric substances slowly reacting. It's a slow process. Corrosion isn't breaks. It's an unwanted change. No one desires that the iron things in their homes to get rusted. So it's an undesirable change. It takes place slowly over a period of or months of time due to the attack of atmospheric gases. Not only gases, it can even be humidity, that is water vapor, etc. Generally it's oxygen, CO2. It takes place. For example, iron gets rusted. It's called as hydrated iron 3 oxide. It can be prevented by painting. It means you can, for example, if there are the pipes of the water tanker on your apartment or in your house, you can paint them with any other paint so that the surface gets a coat. So this is a iron rod. You can paint it with some color, any color, so that the surface is protected. The surface contains paint. The air doesn't comes in direct contact with the the tube, so that it doesn't get corroded. Okay, the galvanization is you apply a layer of zinc on the surface of the metal. Oiling or greasing, it's normal. So if, for example, if there is a fan, due to the long usage, what happens is that it gets the parts of the ball bearings get corroded, so that if you put some oil, then it starts to run smoothly. Okay, the corrosion of aluminium has this advantage. It's one more thing is also important here. For example, most people don't understand this point. This is very important. It's very important here for aluminium. And what happens here is that, for example, there is aluminium. You take it. This is an aluminium rod. Okay, you didn't take care of it, so it got corroded. Okay, then what happens is that the corrosion layer form on it prevents the iron rod from further corrosion or other damages. So since only it forms as a protective layer of corrosion for Al2O3. Okay, and the thing is, next topic you learn is rancidity in the next chapter, in the next video.